Hello, everyone. This is going to be our second little mini session here on some final topics. It looks like I have about 5 questions for you, some logarithms, and then we'll start our interest formulas. So starting at the top here, we're going to look at a log expansion. This is log base 2 of 16x to the 5th all over y squared. Remember, when logarithms had multiplication inside, that could expand with an addition, and when there's a division, that expanded or broke apart with subtraction. So we're going to start our expansion with log base 2 of 16 plus log base 2 of x to the 5th. And then I'm going to go to my subtraction. This is going to take care of what's on the bottom, log base 2 of y squared. So I've expanded this. You might ask, is there anything more to do? There was another log property we had that dealt with the exponents here and here. And then we'll talk about this at the end. We had a property that log of something raised to a power was equivalent to that power times the log of the base. So I kind of think about it as the 5 comes down. 5 log base 2 of x. Over here, the 2 is going to do the same thing. Minus 2 log base 2y. This is just a number. So there's a couple ways we could handle it. On your calculator, you could type in log base 2 of 16. If you remember logarithms, this was the exponent required on 2 to produce a 16. So 2 to the what power? 16. To 1 to the 2, 2 cubed, 2 to the 4th actually is 16. So all of that just becomes the number 4. It is the number 4. This has been expanded, and this would be my right answer. Okay, next question. Solving a log equation. We want to use the log base b of, let's call this y equals x. And this was equivalent to b to the x equals y. That was a very important log rule you want to know for your final. So to solve this, I'm going to rewrite, start with your base, 5 cubed equals the argument, which is the thing on the inside of the logarithm. This is the question we're really solving. 5 cubed on your calculator, you could type that in. It should give you 125. To solve this, I'm going to add 2 to both sides. 127 equals 3x. Let me use a calculator. I'm going to do 127 divided by 3. I'm getting x is 42.3 repeating. So maybe 42.3. Moving on, our final exponential question here for review. 3 to some power is 81. You can see that. So what I'm going to do is try to rewrite 3. I'm recording a little less than here. That's okay. I'm going to rewrite the 81 as 3 to the 4th. So we would have to know 81 is 3 to the 4th. If I had some other number here, like a 9, for example, we'd write that as 3 squared if we had a 9. 81, that was 3 to the 4th. What we can do now is set those exponents equal. 5 minus x equals 4, and then we're going to try to solve. 5 take away what number is 4? X must be 1. 5 minus 1 is 4. That's all there is to that one. And then switch gears for the last couple minutes here. Let's try a couple exponential, I guess I should say interest formulas. Find the future value of $25,000 invested at 3.125% compounded quarterly for 8 years. So you will have your formula sheet you're allowed to use on your final. And on that formula sheet, you'll find the future value, which is often called A on the formula sheet, equals P, 1 plus rate over N to the T. Let's talk about all these things quickly. A is our present, 2,500 is our present value. That will go there. A is the future value that we do not know yet. What is the rate? So I always reminded you to take the rate and turn it into a decimal. So right now it's a percent. We're going to slide that 2 over 0.03125. N is the number of compounds. So this is compounded quarterly. So if on your final it says compounded quarterly, you're going to use a 4. If it says compounded monthly, there's 12 months in a year, you'll use a 12. If it says compounded semi-annually, that's twice a year, you'll use a 2. If it says compounded annually, you'll use a 1. And compounded daily, we'll go with 365. Quarterly, though, I'm using a 4 for N, and then T is how many years? This question is 8 years. I'm going to type this into my calculator. 2,500, 1 plus the rate divided by the time, or I should say the number of compounds, raised to the number of compounds times the years. 32069 point, let's call it 46 cents. So that is the future value. That went up a lot, it looks like to me. I guess it was 8 years though, but we could gain about $7,000. Last one I want to practice in this mini session is question 8 here. If I want to have $50,000 saved in 15 years, how much should I invest? And I'm getting an interest rate of 5% compounded monthly. So this time we are solving for what? If I want to have $50,000 in 15 years, how much should I invest? That sounds like a present value. The present value, we call P a lot. So A equals P, 1 plus R over N, NT. Same formula. The 50,000 goes here. The P we do not know. The rate is 5%, so that's 0.05 as a decimal. What are we going to do for N? What did I say for monthly? Go with 12. Raised to the 12 times 15 years. That's a long time. Okay, my suggestion to you is to type all of this out on your calculator. That part of it anyway. 1 plus 0.05 divided by 12. Raised to the 12 times 15. I'm going to copy this down. 2.1137. 2.1137. Now that is multiplying the P. Now I'm going to solve for P, the present value. We do this with one division. $50,000 divided by, in this calculator, I can actually grab that answer. 23655. 23655 and about 16 cents there. So, wow. If you were to be able to invest about $23,655 in 15 years, at 5%, we're up to $50,000. Okay, so those are some questions you should study for your final. I will upload the next set of questions soon. Thank you.